Hey guys, so today we're going to be working through a couple questions from Webassign 11.1. Got a slightly different format today because I ran out of dry erase markers, so I'm working on the computer, but it's going to be exactly the same as it usually is, other besides that. So our first question that we have today is asking us to find for what value of omega, or what values of omega, is the equation y equals cosine. Sorry, you're gonna have to bear with the slightly worse than usual handwriting. For what values of omega, this variable here, is the equation y equals cosine omega t a solution to the differential equation d squared y over dt squared, or the second derivative of y with respect to t, plus 16y equals 0. So the way that I would recommend starting out this problem is by just figuring out what exactly that second derivative is. So we'll go over here. So obviously we're going to have to do dy dt first. And just from using that, the derivative of cosine is negative sine, and also the chain rule, we're going to get the first derivative of y with respect to t is negative omega cosine, or sorry, excuse me, omega sine omega t, right? And then next up, we will get d squared y over dt squared, second derivative of y with respect to t. Same idea, negative omega squared cosine omega t, right? So next, all we have to do is just plug this into our equation from earlier, which is going to get us d squared y over dt squared plus 16y is equal to, using this here, negative omega squared cosine omega t plus cosine plus 16, excuse me, plus 16 cosine, not a space, omega t is going to be equal to 0. So at this point, now that we've done all that differentiation, it's just algebra. You can see subtract negative omega squared cosine omega t from both sides, and we then cancel out the cosine omega t term. We're going to get that omega squared is equal to 16, which means that our values for omega for this differential equation are going to be plus or minus 4. And that is the answer to, I guess I should have said this is question number 1 on the Webassign. And that is the answer right there. And of course, I believe this number here is randomized. So it's going to be a slightly different number probably for a lot of you guys, but the same principle applies regardless of what that number is exactly. So next question that we're going to take a look at is Webassign section 11.1 question number 2, which is asking us to figure out for which value of k is the equation y equals x squared plus k a solution to the differential equation 2y minus xy prime equals 52. Okay, so kind of like the last question, what we're going to do is solve for everything in this differential equation and plug it in, and then use that information to then solve for k in this case. So we've already got y here. So the next thing that we need to figure out is, and x is just our variable. And the next thing we'll need to figure out is y prime. We can do that pretty easily by just differentiating y here with respect to x, since it's a function of x. And what we're going to get is that y prime is equal to 2x, of course. So next step is just to plug this into the differential equation. What we're going to get is 2 times y, which as we know is x squared plus k, minus x times y prime, which we just solved for, is 2x, equals 52. And multiplying that out, we get 2x squared plus 2k minus 2x squared equals 52. And then these two cancel out here, and we're left with 2k equals 52. And when we solve that for k, we get that k is equal to 26. Next question that we're going to look at, or last question that we're going to look at, is number 3 from Webassign section 11.1, which is asking us a couple of questions about this differential equation, and the which is y prime minus xy minus 4x equals 0, and this sort of proposed solution, which is y of x equals a plus b times e to the power of x squared over 2. Okay, so our first question is asking us, part A asks us to figure out for what value of a is this proposed solution here an actual solution to this differential equation. So just like the last two problems, you may be noticing a theme here. What we're going to do is solve for everything that's involved in this differential equation. So basically just figure out what y prime is, plug it in, and then solve for a. So first step, as usual, is to solve for y prime, which is going to be equal to, a is just a constant, a and b are both constants. The question says that. So obviously derivative of a is just 0. Derivative of b times e to the power of x squared over 2 is just going to be bx times e to the power of x squared over 2. It's a little bit big there, but writing with a mouse, so just bear with me. So as usual, next step is going to be to plug this into our differential equation. So I've got y prime, which we now know is bx times e to the power of x squared over 2 minus x times y, which is just y of x, so a plus b times e to the power of x squared over 2 minus 4x is equal to 0. We multiply that out, and we're going to get b times x times e to the power of x squared over 2 minus bx times e to the power of x squared over 2, which we get from multiplying this by negative x over here and adding it to that term. Make that a little clear. Minus ax minus 4x equals 0. And as we can see, these two will cancel out. And we're going to be left with negative ax minus 4x equals 0. And then when we solve for a, cancel out those x's, we're going to get that a is equal to negative 4. which is our answer to part A of this question. Now, the next question, the next part of the question, part B, asks us to figure out for what value of B is now this, we know y of x is going to be equal to -4 plus b times e to the power of x squared over 2. For what value of b is that a solution given the initial value y of 0 is equal to 11? So what we're going to do there is just, so we know that this is what y of 0 is supposed to equal to using the equation that we've now obtained here. We also know that y of 0 is equal to just write a as -4 now since we've solved for it in the last part of the question, plus b times e, since x is equal to 0, e to the power of 0, which is just going to be equal to -4 plus b, since e to the power of 0, any number to the power of 0 is just 1, right? So now we can set these two equal to each other. We've got, implies that -4 plus b is equal to 11, which means subtract or add 4 to both sides. B must equal 15. And that is the answer to part B of this question. And that's a wrap.